Hello, everyone, and welcome to today's webinar. I'm Steve Gustinoven. I'm the Marketing Communications Manager for IoTize. And today we're going to present you some ways of rapidly integrating your electronic designs into an MQTT broker, or even into a full-fledged data logging platform on AWS. So today's webinar, just to orient you to the webinar, for today's webinar, all the participants are muted for reasons of bandwidth. However, if you do have a question, you can leave questions in Q&A. There's a little question mark tab, so go ahead and you can just type your question in. I will try to pause as I go through the presentation today and answer any questions that come up. Don't worry if I don't get to your question. I will follow up with questions afterwards and give you as complete a response as I possibly can. So with that, let's go ahead and dive into into today's presentation about MQTT and cloud data logging. So today we're going to look at two examples, one of just a use of a simple MQTT broker, and the other for provisioning AWS and their MQTT broker. And so you can actually see data in a container on the AWS, on your AWS account. In this presentation, we are going to be using an STM32 processor that's associated with our tap and link primer, and using a tap and link module like this. There are two procedures in this demonstration that we'll follow. In the slides, you can see there are links to download the HiveMQ and AWS procedures. So you actually have the full procedures that we're going to go through with all the notes about how to do these demonstrations yourself. So in today's presentation, I'm going to first start off by talking a little bit about a difference to clarify a difference that we have in our jargon when we're talking about data logging versus on-site monitoring. We're going to take a quick look at the IoTize solution and software tools, but then in terms of our demonstrations, we're going to focus on a special tool, an app that we call Tap Manager, and the special features it offers for rapidly connecting your tap and link device to an MQTT broker or to the AWS IoT cloud. Now, to start off with, there's some jargon that we use. We often talk here at IoTize about ideas of monitoring or on-site monitoring versus data logging. And sometimes this generates some confusion because the two approaches are things that are relatively different. Data logging is a technique we're going to use in order to create a log of data, a history of data that we can use to analyze and guide future actions with a machine, a device, or an activity. Monitoring, on the other hand, is something that the focus of monitoring will be with on-site use of a machine or a system, and viewing data live on-site for that system. An analogy that I like to use when I talk to my customers is to talk about, for example, monitoring. Think of monitoring as I'm a cyclist, and so this kind of speaks to me. I hope it'll speak to you guys too. Monitoring, think of it as the application on my bike at the time that I am riding my bike. It's providing me real-time live data, not necessarily historizing all that data or logging all that data, but providing me a view of performance data as it's occurring. The objective being to guide my decisions in my performance. What is my speed? What are my directions? Where do I need to go, left, right, etc.? It's often, in the case of monitoring, we're using local networks, what we call personal area networks or PAN networks, technologies like near field communication, Bluetooth Low Energy, Wi-Fi, and other short range or shorter range wireless connections. And often monitoring is going to correspond to tasks that we have around machines and equipment. It's going to correspond to tasks around that occur in commissioning and testing and maintenance. Data logging, on the other hand, you can think of that as, for example, an app that my wife might consult in order to understand where I'm at in my outing, and to be able to, for example, maybe to compare where I'm at in today's outing compared to my history on the same circuit. We're going to tend to use more permanent long-range connections to WAN, LP1, and GSM networks. And an important aspect of this is that the data is going to be persistent. Excuse me, I just have to take care of a phone call here really quickly. Getting interrupted. Excuse me for that. So in this case, one of the important aspects is that the data is persistent, stored on a platform. It can be analyzed in the future and in order to guide future actions, strategies in how we might manage a system. So for today's demonstration, we're really talking about data logging and how to create that persistent data record, whereas our solution is equally adapted to on-site monitoring and creating the types of user interfaces that might be used for that monitoring. Now, where does the solution come from? Essentially, IoTize has a long expertise in providing tools for embedded systems designers. Designers creating systems in appliance, HVAC, energy automation, a wide range of different types of products. And with this, we developed extensive knowledge or expertise in wireless and mobile apps, use or interfacing with mobile devices, cloud platforms, and security mechanisms, encryption, authentication, etc. And all of this has come together in a solution that we intended to provide initially to OEM device manufacturers. Why is this? Well, that's because for years now, many manufacturers have been finding themselves in a race to connect things in order to meet changing customer expectations for how they interact with machines and what they can see about the machines and products that they're using, to develop new efficiencies in how we use those things, whether they're appliances or whether they're industrial equipment, and essentially also to develop new services and new businesses around this connectivity and the services that we can provide to owners and other types of intermediate users of them. Now, the challenge for OEMs and designers is that these kind of connected products invoke a lot of new technologies out there, different types of connectivity technologies, mobile devices that they may not be useful, they may not be used to, different types of networks that they won't be familiar with, and security mechanisms. This has also increased the complexity of their designs, going from a world that they once mastered, their embedded electronic design, to a connected world where that implicates other types of infrastructure like servers and networks and all of the people who can intervene in those. Now, the challenge for companies is, of course, eventually certain lack of expertise in different facets of these designs, and also, more importantly, the lack of resources and time in order to develop those products and keep pace with the changes that are occurring in our market today. And unfortunately, being too slow to respond to these opportunities that are rising around connected devices is equivalent to a lot of lost opportunities, lost business. And we want to help our OEM customers get over those challenges so that they can be part of this IoT revolution. In order to do that, what we did was we came up with a solution, a no-code, low-code solution for creating connected objects. It is a combination of wireless hardware, embedded software, and a tool ecosystem to help them leverage what we've done at the embedded level of our hardware. Now, in our solution, you'll see, if you take a look at the website, you'll find that we provide both modules like you see on my desk here that are dedicated to embedded systems designers or use in embedded systems. So these are the tap and link NFC Bluetooth wireless modules. But these are also used in an extensive range of industrial devices that can be used as add-ons for existing industrial equipment. Now, our focus today is going to be talking a lot more about the kind of embedded modules like this, but everything that I talked to you about is pertinent for those industrial users as well, too. Now, as we talk about this solution, oftentimes we focus a lot of times about the hardware format of these devices, but it's also important to recognize that what is crucial to this solution and the fact that it's a no-code, low-code solution and the advantages it offers are the embedded software. We'll take a quick look at that, and the software ecosystem. Our embedded software actually has two components. One of those is what we call the LWM2M engine. This is entirely pre-implemented features of the wireless component that encompass security, communications, data handling, everything you need in a connected device so that the designer doesn't have to actually code all that. And then it complements that with a Java virtual machine. This JVM allows us to do, with a little bit of code, things like edge processing, additional data handling, and integration with, for example, cloud platforms like AWS that we'll see today. Here's a little more detailed look at that, and here you can see the LWM2M is responsible for the fundamental communications that allow us to integrate easily and rapidly with your electronic designs, even retrofitting your existing designs, and without modifying the code within your existing system, and also communicating with the outside world, notably with mobile devices, but also with our integration with other networks like WAN, LP1, and GSM networks. In complement to that, what brings our no-code flexibility, our low-code flexibility, is that Java virtual machine, which is going to allow us to communicate with other types of electronic devices, like add-on sensors, for example, over other types of interfaces, or to do local data processing and to prepare data and send data and messages to cloud platforms like we do with AWS. Now, behind this, as we mentioned, we've taken a look at the embedded software. In complement to this, we provide a complete professional software ecosystem. That software ecosystem is everything you need to configure those configuration-only features, add code in where you need to customize those features, and then generate user interfaces that allow you to exploit that the connectivity on mobile devices, or even to integrate them with cloud platforms and visualize data in dashboards. Now, in complement to this, we offer a specific tool called our Tap Manager mobile app. This is a tool that's particularly interesting in two cases. One, if you're a designer who wants to do a rapid proof of concept, you don't want to spend a lot of time learning new tools and coding things, you can rely on Tap Manager, and we'll show you how, in order to rapidly configure your device for your system and create either monitoring interfaces or configure that device to integrate with a cloud platform. Now, that Tap Manager app is actually we'll say a subset of our professional software ecosystem. The IoT app creator, app generator is actually all based on the same technology, the same software is used both in that professional ecosystem and our Tap Manager app. The full professional system like I mentioned, is equally adapted to our embedded modules and our industrial devices, composed of software for configuration that runs on your PC, particularly adapted when you need to have a configuration that you will apply to hundreds, thousands, hundreds of thousands of connected devices. So really particularly pertinent when you need to have something that when you go on to the industrialization of your solution. And then the IoT app creator, which is going to allow you to create visual interfaces for interfacing with your connected systems or for visualizing data coming from those. Regardless of the system you're working with, where there's a common workflow of configuration in IoTize Studio, creation of user interfaces, validating those as dynamic apps, and then generating, in the case where you're going to generate a user interface, generating those on using our cloud-based tools. The data logging workflow is a little bit different in the sense that in a normal data logging workflow, you're going to have to do a certain amount of preparation on your cloud platform of choice. And this is one of the things we're going to look at today, is we can actually expedite that process for you. And we'll see that in the demonstration, notably for AWS today. However, the same type of things are done, where in IoTize Studio, we're going to configure our hardware, providing it the cloud or the material context. What is it connected to? Adding in Java code that corresponds to your cloud setup and manages your certificates, and then saving that configuration on the hardware so that it can then interface both with your electronic design and with your cloud, your network and cloud platform. Now, in the case of Tap Manager, that workflow can seem a little complex, what you just saw, and it will be necessary at some point for you. But with Tap Manager, we can access that same result much, much more rapidly with a very simple configuration through the wizards that we provide in that mobile app. And now I'm going to be using Tap Manager to kind of help us view what we're doing. I'm going to be using Tap Manager running as a web app on my PC. But I just want to show you here on my mobile phone here that in fact the same app, it'll be exactly the same interface that we'll see. The same app can be installed on your mobile phone and run on your mobile phone. So you can completely forego any software installations other than adding a new app into your phone that then is capable of connecting to your Tap and Link wireless module or your Tapioca industrial device. Now, you're going to see that because our Tap and Link module runs, generally speaking, off of a kind of a generic configuration, there's actually very little information we need to provide it in order to interface with your electronics and to interface with your network and your cloud platform. And so it's a very simple process that we're going to do, where we simply have made our electrical connections. We connect our mobile phone to our Tap and Link device, and then we define its material context. What is it connected to? What network is it connected to? What hardware by what interfaces is it using? We're going to import the variables that we want to access and log to our cloud platform or send data via our MQTT relay. And then we're going to set a few data logging options. We're going to save that as a configuration in our Tap and Link module. And then we'll see that we'll virtually automatically be able to see data coming from our system on our mobile phone in the case of monitoring, or see messages and logging via either an MQTT broker or actually seeing data also on our AWS IoT platform. So it's a very, very simple process: defining the context, importing the variables or registers that we want to access, setting those options, and then saving that configuration to our device. So let's go into the first demonstration. The first thing I want to show you is how easy it is to set up an MQTT broker. So we're going to start with a simple demonstration of the wizard for connecting to the Hive MQTT broker. We're going to be, to do this, we're going to be using what we call the Tap and Link Primer. The Tap and Link Primer consists of an STM32 application board that you can see here on my desk, which is connected via a minimum of two wires, the SWD and the three wires and a power supply. It's connected to our board. And then keep in mind, this board is running its own independent firmware. It has a simple application that's recuperating temperatures from internal sensors. It's not a complicated firmware, but it's a basic firmware that you can use in order to learn how to configure the Tap and Link module in order to capture that data and bring it to a mobile phone or a cloud platform. And what we're going to focus on is how we use then Tap Manager, the app, to configure this Tap and Link device in order to connect to our network and bring data readings to the outside world. So I'm just going to set that down here. We'll be connecting to this device here that's on my desk. I'm going to switch over now to Tap Manager on my PC. So just so you know, so Tap Manager runs from PC in Chrome as what we call a web app. Essentially, it's a web app. It's the same interface as we see, as I mentioned, here on my mobile phone. And so on the mobile phone, we can actually connect in exactly the same way and do the same configurations. In the case of the MQTT broker, it's equally easy to do this configuration on the mobile phone or on the PC. It's just a little easier to see on the PC. And with AWS, it's maybe a little bit more complicated because we'll have to switch back and forth between our AWS account and the Tap Manager. So that's just a little bit easier to do on the PC than it is to do on a mobile phone. Now, my device here, when we're on the mobile phone or when we're on our PC, we'll be connecting to Tap and Link using its Bluetooth Low Energy interface. So when I want to go and connect to something, I can go here and select a device. I'm sorry, I have to quit that device. I'm just going to go here and select a device. This is the basic interface. Click on the little glass down here. This is my module that we're going to set up for MQTT, to use the Hive MQTT broker. I'll just connect to that now. And because it doesn't have a configuration already, it automatically, Tap Manager launches my configuration wizard. So you can see here the first screen of the configuration wizard, and then down the side of the screen here, it's just steps. So we'll be able to see where we're at in that process. The first thing we do is ensure that we're connected to the right device. We select the device type because there are a wide range of IoTize devices, but this is the same process no matter whether we're using a Tap and Link device like the one I have, or one of our industrial products, or any of the other devices that we provide. In this case, we're using the Tap and Link NFC Bluetooth Wi-Fi device that we mentioned. I'll just click OK and click Next. This screen is showing me that I've already associated this device. When you first purchase a Tap and Link device, you'll want to associate it with Tap Cloud, because Tap Cloud is, you'll have an account on Tap Cloud, and it allows you to administer your devices, and it actually provides you an easy access like this to Tap Manager. So this one's already correctly associated with my account on Tap Cloud. I'll click Next. Here, now normally these will be blank, but I'm reconfiguring this device, but I'm going to want to enter a device name. This is the standard device name I give to all all of my sensors. It's not extremely important here, but it is interesting to enter device type, because this is a category that will allow you to organize your devices that you'll be connecting, for example, to a cloud platform. And this will allow us, for example, in the case of AWS, to create certain resources, for example, containers, just once for storing our data, and it will bring together data from several different devices. But we'll see that in just a moment. But these are names that I give to my devices in order to categorize them. I'll click next after I've done that. I'm going to here enter the wireless network I'm connecting to. So that's my ID and its password. And then here in the next screen, you can see that I have this choice of different MQTT options. Now, of course, I can choose to use this. In the case of pure monitoring, we might not use any kind of MQTT at all. We may just want to go and connect directly by Bluetooth or Wi-Fi to our device and see data directly real-time on our mobile phone. However, you have a choice of other MQTT options. Tap Cloud MQTT Broker is one that we use for design purposes. It's not really for deployable products, but it's a place where you can use to connect by MQTT to your Tap and Link or other devices in order to manage them, do firmware updates and things like that. AWS Broker we'll take a look at a little bit later on. We'll look at this option. This is the second wizard we'll look at today. But then within custom brokers, we have two wizards for connecting to Mosquito or HiveMQ. I'm going to select that one and click next. And then for those wizards, we just select the orange block up here, and you'll see that I have these options of HiveMQ and Mosquito. And this allows me just to set some standard settings for accessing the HiveMQ MQTT broker, so that we have an example to work from. Here's that configuration and my device ID. I'll just click next now. These are the topics that are used by the LWM2M engine if we're using the MQTT broker for monitoring. And that's to show, and we'll take a look at that. We'll show you a monitoring interface and what a monitoring interface looks like here as well. But we're going to see where we're using that MQTT broker to send data logging information, and which is, keep in mind that difference between monitoring and data logging. The objective being to send messages via the broker that my cloud platform can access. Now, we've done everything at this point for connecting to the network and connecting to an MQTT broker. Now, all we have to do is specify how we're connecting to our electronic system. In this case, I'm going to, for rapid proof of concept, I'm connecting my Tap and Link to my microcontroller's debug port and interfacing with it over SWD. Now, you can also do the same thing over another protocol that we call S3P, which uses 2 GPIOs, but using SWD is a way that we can do this without having to modify the code of this processor at all. So keep in mind, it's running its application. Here, I'm going to go, and now you can enter variables manually, but one of the great ways that we can enter our variables into our configuration is to go and select the ELF file that we use in order to program the firmware to our target STM32 device. In fact, this is the ELF file for this sensor application here. I'm just going to open it, and Tap Manager parses that and extracts the information about the different variables that we have right here. For example, on our board, we have this green LED that blinks on and off, and that condition is managed by the LED status variable right here. That's the variable that tells us when it's 0, it's off, when it's 1, it's on. We're going to log that one so we can see that one. We're going to capture the CPU temperature right here, and we're going to get the VCC, the voltage, right down here. So I just select those and click next. Now we can also select registers using the SVD file for our STM32, but I'm not going to do that today. We're going to skip over that directly. So here are my variables. I'm just going to enable the data logging, and I'm going to set this for 15 seconds. So we'll send a message, the data log message, every 15 seconds. That way we'll have a significant number of MQTT messages. You won't have to wait a long time for that to see those messages come up. So we've enabled data logging. We've set each of them to log at 15-second intervals. We'll just click Next now, and we'll simply apply this now to our tap and link module right here. Keep in mind, I connected by Bluetooth Low Energy, so the configuration is being sent through the BLE, the tap and link's BLE interface. The Wi-Fi interface we've actually configured to connect to our network, as I mentioned before. So we'll just apply that. Here it's writing the configuration. We'll have to reset that, but then we'll go over here and we'll see on the MQTT, on the Hive MQ site, where then we'll be able to see those data logging messages coming up after we start data logging from our tap and link module. There we go. My tap has been configured. It's asking me to reboot and restart that. So I'm going to go ahead and do this. There we go. We just did and we're going to leave Tap Manager just for the moment, because what I want to show you is that now that we have configured our module, it is capable of interfacing via BLE still. But we've gone and we've disconnected from the device here. And what I want to show you now is that we should be permanent or connected now to my mobile phone network. We'll just go and take a look there to verify that. Because essentially I've set it to connect to use my mobile phone as its mobile network. Now this can be any one network that you would be using. I'm going to go to network sharing here. And we can see now that I'll turn on that access point and we should see that device. So we just saw the device came up on my phone here. So my tap and link is now connected to the mobile network, my WAN network. And if we go over here to the MQTT interface provided by Hive MQ, we'll see that data log messaging. So we just saw one come up there. This is essentially just my topic that I'm subscribed to, IoTize tap TNL sensor. And every 15 seconds, we'll see a new message coming up here. That is the data coming from my device, the LED status variable, the temperature variable, and the voltage. And essentially, from this, you can access these messages. Keep in mind, this is also a bidirectional communication. So we can also publish messages to our MQTT topics if we had writable variables. In this case, I'm just treating this as readable. And we can actually subscribe, in a sense, to these MQTT feeds in order to capture data coming from my target board here. So I'm just going to switch back to our presentation here. And let's just summarize what it is we've done. We've gone through a wizard. We went through a simple configuration and configured our wizard to connect to our WAN network and our Hive MQ broker. We've selected specific variables from our target system to log to via the MQTT broker. And we've gone over to Hive MQ, and we've seen those messages now appearing. They're publicly available. They're things we can see. You can go to, I have another similar application on my phone here. If we go to my MQ, we'll see exactly the same thing where I'm subscribed here. I'm connected to the hivebroker.com, and I can go and enable my topic, and every 15 seconds we should see a new topic published and received then in the HiveMQ via HiveMQ in this separate application. So essentially, we've shown how we can create very easily with very few parameters the implementation to send data from our system to the exterior world. What we haven't done, and what you still need to do, is to prepare your cloud and set up cloud monitoring and connect it to HiveMQ. Now you can use the HiveMQ does provide its own cloud platform and everything, so you can go and do the same thing on their cloud platform. So if you choose to, you can stick with that, or you can actually use that MQTT broker to access data on another platform. Okay, so that's interesting, but maybe not quite as far as you'd like to go, because a lot of us are interested in actually seeing, as we mentioned, what's interesting in data logging, seeing that data on our platform so that then we can access it from other applications, analyze the data, and use that as material for providing services, providing features, or using features in our target system. So we're going to show you how we can do that. Just recently, we introduced on Tap Manager our AWS provisioning wizard. It's doing exactly the same thing, but we're simply going to go a step further, where we're actually going to start using the MQTT broker. It'll be AWS IoT MQTT broker to send data to containers on your AWS IoT platform. So you'll have persistent data that then you can import into another application. So in order to do this procedure, you do have to create beforehand an AWS account. And I just need you to know that AWS will ask you for a payment method, and they will make a $1 transaction in order to ensure that the payment method that you provide is valid. But rest assured, I've been logging data from multiple devices for 3 or 4, actually almost 6 months now, and have yet to pay a penny to AWS for the use of their platform. So you can actually do a lot of testing, a lot of validation before you ever get into really paying for data on the AWS platform. So rest assured, when you see that, it's not something that's going to cost you an arm and a leg, especially if you're just doing that initial testing. So once you've created that AWS account, you can simply go back to your hardware, as we've done here. Now I'm going to switch modules here and use a different unconfigured module, this one. It's essentially the same thing. It's a slightly more recent version of the IoTize Tap and Link NFC Bluetooth Wi-Fi module. It is unconfigured, so when I go and connect to it, we're going to see in Tap Manager that is automatically going to launch that configuration wizard. So let's go switch over to that. I'm switching over to to Tap Manager now. So have I lost my Tap Manager? Oh, there we are. Excuse me. So I'm switching over to Tap Manager now. And here we're going to go and connect to a new device. I'm just going to go ahead and get out of this device. That's the configuration that we just finished. We'll notice here that I'm in the main screen for Tap Manager. I'm going to go and connect by Bluetooth to my other module that I just connected up on the board on my desktop here. There it is right there, the Tap 136F. I'll connect to it over its Bluetooth connection now. And you can see that it's been reset. Now, this has been reconfigured several times for AWS. So I want to say this ahead of time that I already have the certificates for this device, but I will take you through the wizard and you'll see where we create the device certificates in order to create the secure pairing between our device and the AWS account. Now, this is operating from, right now we're in unconfigured mode. So what we're going to do, I do need to log into my device. There's a standard administrative login that we provide for all the devices, so that you have to be logged in order to apply configuration. And now we're going to launch this configuration of our tap. You'll see that it has correctly read my tap and link serial number. Again, we select the device that we're connecting to. Again, this is an NFC Bluetooth Wi-Fi type device. We can see here that it is associated with my account. I'll click next. Now here, I just want to correct the name of the device. That's the name of the last device we connected to. This one is 136F. And again, remember I mentioned we have this device type. So here we're connected to we're configuring another TNL sensor device. And this is the reason I use this name is because I've already configured another device just like it. And so that will allow us to see data logging for a device on the AWS sensor. So in this way, I'm only configuring certain resources on my AWS account at the same time, everything that's associated with a tap and link sensor. Now, if I had a tap and link motor or a tap and link switch, I might give it a different name in order to separate those things out and store the data in different containers. So now that I've named that device, I've given it its type, I'll click next. We're connecting to the same network, so this is correct with the SVG, I'll click next again. And this time in MQTT provider, we're going to select AWS, click next. And now we see we have a much more complete set of things to do, because what we're going to do now is we'll switch back and forth between Tap Manager and our AWS account to create our certificates, import the different information that we need in order to make the link between our device and our AWS account. The first thing to do is, of course, just go ahead and sign in and sign up for account. I'm signing in right now. In fact, I was already signed in. That's good. There we go. So I'm signed into my account here. We'll go back. You'll need to create a certificate. Now, I've already created certificates for my device, but when you click on Create Certificate, the wizard brings you directly to the place where you need to do that. You will simply select Auto Generate New Certificate, and you're going to want to click that it's an active certificate. That means it's something that will actually be active and used. You'll click on Create, and when you do that, IoTize or the AWS interface is going to give you it's going to create those certificates and give you the opportunity to download those certificates. I want to emphasize this. Do download your certificates and store them locally when you get that opportunity, because there's at least one of those certificates that you will only have that opportunity to download it, and you won't be able to come back into the system and download it later on if you need to recuperate it. So you'll just click Create here, and it will give you that. It will create those certificates and give you the download option. As I mentioned, I've already downloaded my certificates. So we're going to go back to Tap Manager here. Step B, we've downloaded our certificates. I need to go and now configure in my AWS configuration. I need to get the endpoint for my AWS account. So again, I'll just click here. It takes me to the right spot. Here is my device data endpoint. I'll simply copy that. We'll go back to Tap Manager and we'll paste that here. Now I want to go and get my certificate ARN. Again, click on the link that's provided. it brings you, these are my certificates that I've already created. This is the certificate for the device that we are configuring now. I just click on that. And in here, you'll find the ARN. Simply copy that, go back to Tap Manager, and provide that to Tap Manager here. Now, the last thing we'll have to do on this screen is to go and select our certificates. So we're going to need the PEM certificate. I've already stored my certificates, so we'll just go click Import from File here. I need to go to my desktop, my AWS certificates. There we are. My new certificates. This is the device where I have, and here's my PEM certificate. Just select it and open. You'll see the information about that certificate there, which this becomes then part of our device configuration. Then we need to get the private PEM key from what we have downloaded. We'll import that from File. Here's the private PEM key. Open that, and we've captured that data as well now too. We'll click on Next. Now we're going to return to the AWS configuration. Here we've basically set up, identified our device and our account for that device. Now going back again, we need to configure our device for the system it's connected to. Again, for a proof of concept, use that SWD interface. Click on Next. Select the ELF file as we've done before. I'm going to have to go and look it up here. I believe it's this one. That's the one. I import that. Go and select my variables. Like we said, LED status. We'll just do the same ones again. Temperature and the voltage. Click Next. We're going to skip the SVD registers. We're going to enable data logging. I'm going to do this every 30 seconds so that it's so that we can see some messages and some data in our system. Now you can set those as you wish, depending on your use case. You'll want to set your data logging that corresponds to the period in which you need to see that. You need to see the interval in which you need to see data. We'll click on Next, and now we're going to complete the AWS provisioning. So the first thing is, now this is a computed ARN. We're going to accept these things with the exception of, you see this on step 2, I've already provisioned a device of type TNL sensor. I'm going to click Yes here. Yes, I have done that because I want to reuse resources that are already available. Now we're going to download a template from Tap Manager for our AWS Cloud Formation. And we'll provide that then to the AWS format. So I'm going to download that here. It'll be put in as a JSON file, we can see here. Once we've downloaded that, we can now go to the Cloud Stack Formation. So the first thing we're going to do is we're going to specify that we're going to use the template that we've just downloaded. So click here. We're going to choose an existing template, and we're going to upload a template file. I'm going to go choose that file from my downloads. There it is right there. Open that. There we go. And then I can click, I'm going to check one thing here really quickly. From there, so we provided our template, click Next. And then we're going to go back and we're going to provide it with the stack name. This is a stack name that's been computed here. So I'm going to copy that. So remember we said click Next. Here's our stack name. Just paste that stack name there. Click Next. Now we just are going to review some standard information. We're simply going to accept the defaults. And now you can get into the details on those defaults and read the documentation and change the defaults if you want to. We're just going to accept those things, and then we're going to submit the build of our stack. So let's click Next there. These are the different options about different types, how resources are managed, the types of permissions that are available, stack policies, etc. We're going to stick with the defaults there. And then here we can simply review what it is we are creating, the stack we're going to create for our new device. Now I am creating a second device. At the bottom here, typically if it's your first device, you will have to accept a condition from AWS in order to continue. We don't have that because I've already accepted that condition for other devices, but you'll see more details about that in the full procedure. So we're going to click on submit here, and we're switching over. You can see now here we are in the stack creation. This is a stack that I mentioned that this device has already been, we've already created a stack. It's already set up for data logging. Here's our stack in progress. When it is create complete status, then it will have started, it will be ready for logging or receiving logged data logs from our device. And then here we can see in the creation in progress, you'll see a lot of messages about the different resources that are being created for that stack. And you can follow the creation of the stack if you want to. This often takes a few minutes. So let's go back to Tap Manager again. We've gone through this process. Let's click on Next. We're going to apply the configuration to our Tap and Link module. So it's already been applied. We're building the stack on the AWS side. Now we need to provide the same configuration and the certificates to our module. We click on Apply. It's writing the configuration, and then we'll have to reboot or restart our module. There we go. It's applied the configuration. We're going to go ahead and restart. And at this point, we can leave Tap Manager, because Tap Manager will have configured this module to use the available JVM in order to manage data logging with our AWS platform. So that's going to consume that, and the management of its certificates are going to consume its resources, its available resources. So with that, I'm just going to go ahead and switch over to our cloud platform. Here we can see the stack has been created. I'm going to draw up here another set of windows. Now on the AWS side, you can access a whole bunch of different resources, applications, and such. I'm just going to pull this up. So here's the same window. We can see the stack formation. In the same way we saw in HiveMQ, we have a test client. Here's our test client, our topic, and these are data logging messages that should be coming from our newly provisioned device. Now here are these are older messages that came from earlier today that showed our device was connected. It may take just a moment for our device to actually start logging to the platform. I'm just going to go and double check and make sure it's connected correctly to the network. There we go. I see that it's connected to the network. And then it should start data logging. There we go. There's our first message that just came up from our newly configured device. We can see the status, temperature, voltage, the device identity, and this is our timestamp that corresponds to our time of sampling on the target device. Let's switch over. In AWS. We also have now created the containers to receive data with. So if we switch over now to, this is DynamoDB. It's where we've actually created the database that's receiving our data. I'm just going to do a refresh here because we should start seeing some data coming from the new device. Excuse me. And so here you can see these are earlier data coming from our other second configured device here. But here is a new data record that just came in from our newly configured device 136F. So we can see here then that we have data coming from our new device. And now, and this data is persistent. Now we can use this data, this database, to view and analyze the data so that we can provide it to different apps. I'm sorry, so we can actually, from the database, provide it to different apps where we can analyze then the data and what we're capturing, what we're seeing, eventually providing product updates or services related to the information that we see about the product itself. Let's see, we should have probably a second data point that just came in. There we go. We're up to 2 data points now. So you see that we're now recording persistent data on our system. So let's go back to our presentation here really quickly. We're gradually running out of time here, so I want to wrap this up cleanly for you. So what have we done here? We went through a process of using our AWS MQTT wizard to set up the AWS broker, to select data and configure it to log that data via our WAN network to the AWS platform. And we've actually provisioned containers and created the stack that are required by AWS in order to manage that device connection and send the data to the correct containers where it's stored and can be accessed by other applications. Here we've taken a look to see where we saw then the MQTT messages arriving and the data accumulation that's occurring on our AWS platform. And now, what do we still need to do? We still need to go and create an interface, a dashboard, or integrate that data into an app. Here you can see just a quick dashboard that I did. In fact, the blue readings here are from my test device here. It's a device I commonly use to check how the AWS platform is working with my devices. And here in the orange, you can see the device that I used commonly for these webinars and presentations. So you can see basically what's occurring with those devices over time. And that amounts to about, that's probably about 3 months or 4 months of data accumulation there. So you can see that we have data now that is stored on a platform that we can then exploit and analyze however we might want to do it, and utilize in either in our dashboards in order to maintain or to supervise fielded equipment, or that we can use as a product supplier in order to analyze how products are used and provide new replacement products, services, or whatever it is you may want to do around that data. And that'll be really where you want to focus your attention, as opposed to how it is you create that data logging. So here you can see that the wizards that we provide through Tap Manager provide a very easy method for creating either simply an MQTT data feed that you can exploit, or a complete AWS provisioning. Now, where to go from there, of course, you will want to use the IoTize tools when you start ramping up and going to a full scale up of your connected system or device. And that is because it will be easier to manage one configuration and adapting it to multiple devices so that you can deploy 100 devices, 1,000 devices, 1,000,000 devices with the appropriate configuration to log data and to your supervisory platforms. And it's in those professional tools. Now here we used standard configurations. It's in the IoTize professional tools that you will have access to the Java code and the Java virtual machine so that you can adapt Java code for your specific needs. For here we did AWS, but that same Java code can be adapted to use any type of cloud platform you want, whether it's a private cloud platform or another commercial platform like Watson or whatever you might want to use, Watson, Azure, or whatever else you might want to use. So just to wrap this up, a few concluding points, things to remember as you go forward. The core of the features I've just showed you are a common core that is duetware that's used in all of our products that give you pre-implemented features and that allow you to use those features in everything from industrial wireless devices like these to a wide variety of wireless modules that cover NFC, Bluetooth, Wi-Fi, LoRa, and eventually coming soon LTE and NB-IoT. We've seen how it's easy to use that because of the way we've implemented duetware. We can, from our Tap Manager app, rapidly and easily create a configuration for any of those devices and start logging data, either simply providing it through an MQTT broker that anyone can access, or providing it and linking it directly to our AWS IoT platform. Now, in order to do that yourself, all of these resources are provided for you. Here you have links to the different procedures we've just covered. The hardware that you see me using on my table here is available through IoTize and through our distributors, which include Mouser and DigiKey. So Tap and Link Primer is available worldwide for your use. You can sign up today on the IoTize Cloud. There's a link to our IoTize Cloud, and use Tap Manager as I've just shown you to do this type of configuration. Or you can go to either Play Store or App Store and download the Tap Manager mobile app and use it directly on your mobile phone, connecting to your Tap and Link via Bluetooth, for example, and doing that configuration that I showed you directly on your mobile phone. So very accessible, very easy. So I do encourage you to try it today. And I hope that you'll be able to set up your data logging. I would like to know how you fare. Okay, well, thank you very much for your participation today. It was a great pleasure to show you these tools and these developments. And I hope that you'll be able to join us and talk about your examples and your experiments soon as well. Thank you very much. Have a great day.